Exercise 3.1, we have a closer look into scales for the shape aesthetics. So we are taking the PCA plot that we did previously, where we have the shape by group and color by age. And by default, the control group would then be represented by a solid dot and the HCC group by solid triangles. And we want to use the scale shape manual function to change the shape to squares for the HCC group. For that, we will have a look at the PCH function help page. And then we can use shape numbers 21 and 22 for the two groups and see what happens if we set the fill and the color aesthetic to two different columns. And then as an advanced exercise, we can use the column tumor staging for the shape aesthetic. And then we will see why some data points disappear and how we can prevent this. So we will first read in the data set from the PCA and recreate the plot, but with the different shapes. And then we have a look at the PCH help function. This is the help function actually for the base R graphics, but it has quite some nice table here where you can see the mapping between a number and the shape. So because we need to use the numbers. So for example, a solid dot would be a 16. A solid triangle is 17, which was the default, but we want to have the square, which is 15. So we use the scale shape manual function and set the values to 16 for the control group and to 15 for the HCC group. When we do that, you will see here it uses the dots and the squares. Now we use the shapes 21 and 22. We can have a look here on the help page. 21 and 22 are also circles and squares, but these gray ones here, and this is also what is standing here in the help page, they can be colored and filled. So they have a color for the border and a fill for the inside. So we can use here the color as the group variable and fill for age. And then we can see what is happening. We have here the age, which is a color bar, and you see that that the circles are in a red border and the squares they have a blue border. So this is basically the color aesthetic, and this is here the fill aesthetic, and these shapes here from 21 on have both, while the others only have color and no fill. In this step here, we are using the tumor staging as a shape. Can run that. And compared to the other plot, you see that all the control samples are gone. And this is because for the control samples, no tumor staging is given in the dataset, because it makes no sense. But the default for missing values is also to have no shape. You see it here. NA is a category here, but it has no shape. The points are not printed. And what we can do is to use the scale shape discrete function and set an NA value to 5, which is diamond shape. And if we do that, you can see that the control group samples are plotted now with this diamond shaped dots. In exercise 3.2, we will look at scales for color. So we again take the PCA plot generated in the previous exercise, and then we color the points by group, and then we change these default colors to two of your favorite colors. There's also a website where you can pick colors by name. You can simply use the hexadecimal code of colors, for example. And as an advanced exercise, we color the points by tumor staging and then use a scale from the R-Color Brewer package to change the colors. And we also have to remember to set a proper value for the NAs. Okay, so we open the dataset again, and you see that we have here color as group, and we can use the scale color manual function to pick two colors for control in HCC. In this case, I used Orchid and Royal Blue, and you can see that RStudio has some quite nice option here that the colors are actually printed in the colors that they represent, so you can directly see how the color would look like. Yeah, so this is what the plot looks like then. And in the second part, we will use tumor staging. We will use the scale color brewer function. We choose set2 as the color palette, and we choose black as the NA color. And then you can see here that it uses 4 different colors from this palette and black as an color for all the control samples that have no value for tumor staging. In exercise 3.3, we're looking at scales for fill. So we take the box plots we did in exercise 2.6 and use the column H to fill it. And again, we use the R-Color Brewer package to change the colors. And yeah, we first read in the long data format again. You can see that we use the name, so the sample names on the x-axis, the log2 intensity on the y-axis, H for filling. We use the geom box plot, and in this case we have to use the scale fill distiller because we have here a fill, not a color, and distiller because we don't have a discrete color coding, but we have a continuous variable for color, which is H. So this is what scale fill distiller is for. And here we choose a palette containing purple colors. And you can see here what it looks like. So we have dark purple for young patients and very light purple close to white for very old patients. In exercise 3.4, we will look at another example for scales, which is the scales for line type. So we recreate the line plot from exercise 2.8 and then choose different line types for the genders. So in this case, with the function scale line type manual, to choose dotted and long dash for the 2 genders. And as an advanced exercise, we will use the column H for line type and then see why this gives an error and what would be the alternative. So again, we read in the long data format. We filter it for the specific protein we want to plot in this line plot. And then you can see this here would be the line plot. If I add line type for gender, you see that the females are now a solid line and males is a dotted line. But we want to have dotted and long dash, which we can add with the scale line type manual function. So have dotted and long dash in this case. And now we try to do it with line type SH. You see it doesn't do anything. It gives me an error message. Basically, it says a continuous variable cannot be mapped to the line type aesthetic. So it's not possible to have a continuous way to plot the line type. And it says that we can choose a different aesthetic or use the scale line type bind, which basically constructs bins. So it discretizes the age. So you will see everyone under 30 gets a solid line, from 30 to 40 a dotted line, from 40 to 50 a dashed line, and so on. And the question was, is this a good way to represent the data? And I would say no, because it's really hard to distinguish this. It's really hard to distinguish the different line types. Also, discretizing is maybe not ideal, so it would be maybe better to have something like color coding or something like this in this situation.